Hey everyone, and welcome to this brand new DevOps project. In this observability project, we are going to be deploying an Opentelemetry Astronomy shop which consists of 18 different microservices.
Talking about this particular project, I'm super excited. I rated this project as the first one. Like, this is the number one project on my list out of 10 projects because it's a very cool one. We will see as we progress in the video. But yeah, very excited.
In this project, we will be collecting telemetry data such as logs, traces, and metrics from this application to showcase them on Prometheus Grafana for metrics, OpenSearch for logs, traces using Jaeger, Locust for load generation, and many other DevOps tools. This is going to be an amazing project which will showcase your monitoring and observability skills. So make sure you complete this project and also put this project on your resume. Having this project on your resume can definitely increase your chances of getting a job or promotion. Now, to make sure you complete this project without any problems or issues, I have this document created for you, which includes all the information along with screenshots, important links, explaining different important files. So if you want me to share this document with you, comment down Observability DevOps project in the comment section, and I will share this document as a PDF on LinkedIn or in the video description. Let's start. Okay, so I'm here on my computer screen and we are all set to get started with our DevOps project. But before we start with this observability project, I want to provide you with some information that can help you complete this project without any problem. So if you want to complete this project, you can use the official documentation from the Opentelemetry, which has all the information about the project, different microservices used in it, what are different programming languages used, how do you deploy this application. Everything is present on this official documentation. Although I have created my own document to make it more easy, providing you more information about the files that are important with respect to DevOps engineer. So I've also explained Docker Compose file in this and the config file. So if you want me to share this document, comment down Observability DevOps project. And we are also going to be using this GitHub repository. This is the official repository for the Opentelemetry Demo app, and we will be using this to deploy our application. Now that you understood this, let's get into the project. So what is Opentelemetry? Opentelemetry is a cloud-native tool used to collect telemetry data, which includes traces, metrics, logs from an application and then show it onto different monitoring platforms like Prometheus, Grafana, Splunk, Datadog, anything. Opentelemetry is supported by many different monitoring solutions. So you can see the list here. It includes Alibaba Cloud, AppDynamics, Expecto, Logs.io, Dynatrace, Datadog, TotalLogix. All the different platforms are supported by Opentelemetry, which makes Opentelemetry a vendor-agnostic. So you don't have to be using a particular tool to get started with Opentelemetry. You can use any tool. By default, this application uses Prometheus Grafana for metrics. Logs are done by OpenSearch and traces are done using Jaeger. Although you can integrate Opentelemetry Demo project with any of these tools. I will show you an example as well. Along with this, Opentelemetry is also the second best project in the CNCF landscape after Kubernetes, which makes this project special. So you need to have Opentelemetry knowledge as a DevOps engineer because it is a very popular tool, and having this project on your resume will obviously make it shine. This is how Opentelemetry works. So Opentelemetry has a collector which is going to receive the data, which includes the monitoring data such as logs, traces, and metrics from an application which could be running on a system or a Kubernetes cluster, process that data, and then export it onto monitoring platform. And it can work with any monitoring platforms. It can also work with any programming language. In fact, if you check this document here, all these different microservices, which includes accounting service, ad service, cart service, checkout, email, front end, all of them are created using different programming language, just to showcase that Opentelemetry can work properly even with different programming language. So we can see .NET is used to create accounting service, also cart service, Golang is used for checkout, product, catalog service, Java is used for ad service, JavaScript for front end and payment service. So these are all the information about different programming languages used to create this microservices. Although as a DevOps engineer, you don't need to go deep or understand the code used to create these microservices, because we are only responsible to deploy the application and to monitor them to make sure everything is working fine. So you don't need to necessarily understand each and every code about these microservices. It is out of scope. So now that we have all this information about the project, we are ready to get started. And to start this project, you will require an AWS cloud, because we are doing this on AWS cloud using Docker. And you can do this project either using Docker or using Kubernetes. So there are two options you can use. We are going to be doing this using Docker on AWS cloud. If you have a good machine, you can also do it locally on your local machine if you want to, or you can also use Minikube if you want to do it on Kubernetes. But for now, to make things easy, we will do it on the cloud. So you will need an AWS cloud for this, and I'm going to log into my cloud now. So this is my AWS account. Let's go to EC2 service, which stands for Elastic Compute Cloud. We are going to be creating a Linux server to deploy our application. So I'm going to click on instances here. Right now, we don't have any instances. Let's click on launch instance. For this project, you will require an instance of minimum 8 GB RAM, because we are going to be deploying different microservices along with Kafka. Kafka requires you to have good amount of RAM. So we will be using a bigger instance, which makes this project not free. So this project is not free tier project. You will get some charge, but the charge is worth it because this is an excellent project that will teach you a lot of things. So don't worry about the charge, just do this project and showcase your learnings on LinkedIn, Twitter, or on your resume. Let's name this server as Otel Observability Project. You can name this anything you like. So I'm going to be using Ubuntu, and I will be using Ubuntu 22. So this is the Ubuntu 22 version. Let's click on confirm changes. Alright. As I said, we want to be using a server that should have more than 8 GB of RAM. We will go with T2X large, which is 16 GB of RAM and 4 CPU. So this is not free tier, as we can see here. Once you complete this project, you can go ahead with deleting the server, and I will also show you how to delete it. But don't worry about the charge for now, because this is a project that is worth the charge. After you select this instance type, you also need to attach a key pair, because we are going to be connecting to this instance and running some commands. So if you don't have a key pair, you can create a new key pair, but if you have an existing one, you can attach that from here. So I'm going to be using this key, and we are going to set the network settings as default VPC, default subnet. Just make sure your IP address is enabled. For security group, I'm going to be creating a new security group. This application runs on port 8080, so we need to have port 8080 allowed in our security group. I'm going to be adding that security group rule after the instance is created. So let's go ahead. For storage, I'm going to be giving 15 GB of storage, and then click on launch instance. This will go ahead and start our instance. Once the instance is ready, we are going to be deploying our application and then check metrics, logs, and traces. So this is our instance ID. Let's go to the instance now. So you can see instance is right now in pending state. We have to wait for the instance to come up in running state. Till the time it is going to come up in running state, let's change the security group by adding a security group rule for port 8080, because the application is running on port 8080. Click on edit inbound rules and add a rule custom TCP 8080. Okay, let's click on anywhere IPv4 and choose this as app port. Okay, let's click on save rules now and wait for the instance to be ready. So as we know, we can deploy this application either using Docker or Kubernetes. In fact, you can also deploy this application using Make if you have Make installed in your machine. Once you have this application deployed, you can access application on 8080, Grafana on 8080/Grafana, the fake load generator, which is Locust, using 8080/loadgen, Jaeger using this URL. So these are the different endpoints on which we are going to be accessing all the applications. We are going to be doing this through Docker. So we also need to have Docker Compose installed in our machine or in our server EC2 instance. As you can see, this is why we are using a bigger instance rather than using a T2 micro free tier option. So let's go back and connect to our instance. I hope now it is ready. So I'm going to refresh this page and it is running. So I'm going to click on connect. To connect this instance, you can either do it through your local machine, like using your terminal or a PowerShell, using PuTTY, MobiXterm, anything. It will still work the same. For now, to make things easy, I'm going to be using EC2 instance connect. So let's click on connect option, and this will bring us inside the server. Okay, so the server is ready. I'm going to run the command sudo apt update -y and apt upgrade to make sure I'm using all the updated packages. So this is a good practice before you start with any new server, to make sure all the packages are updated in case you got some issues later on when you do this project. So we are going to update all the packages. Once the package is updated, we are going to go ahead with next commands, which is to clone the repository. So we are going to be using the official repository provided by Opentelemetry team, which you can find here. The link is going to be in the description. So we will be using this repo, and we need to clone this repository to get all these files from here into our server. So I'm going to copy this and run the git clone command. Git clone and the repository. All these commands are already mentioned in the documentation here. So I've already mentioned the different commands that you are going to run, which is to clone the repository and then run the Opentelemetry demo. Also explaining the Docker Compose file. So I will explain the Docker Compose file as well, because that is a file which we will use to deploy our application. So now the repo is cloned. If I do ls, you can see a folder created. Let's go inside this, and if I do ls now, you can see all the different files. The most important file now is going to be Docker Compose file. So if you are new to Docker, or if you don't know what is Docker Compose file, a Docker Compose file is a file that contains information about different services and how do you want to deploy them, what should be the dependency, what image should be used, what network should be used. All the information is there. Let me show you this file and also explain you. So this is the Docker Compose file we will be using to deploy all the different services like accounting service, ad service, everything that is required for our application to run. In this Docker Compose file, it starts with logging information that is going to be used by every service. So here is the logging information. Then we define a network that is going to be used by different services so that they can talk to each other and communication should be handled properly. So we are creating a network, Docker network of the type bridge and the name as Opentelemetry Demo. Then we are defining all the different services. So we start with accounting service, define what image is going to be used, what are the dependency for this particular service, what are environment variables, all this information. So we create a dependency in order to define which service should be deployed first, which should be deployed second, and so on. So you can see all the information about different services in this Docker Compose.yml file. If you want to know more information, you can read them here in this document. So I have explained the logging information, network, services. In fact, I have explained each service with proper information. So if you want to go deep and understand the Docker Compose file properly, you can check this document out. Because I don't want you to just complete the project watching this video, you should be able to understand what you are doing and why you are doing it. That's what will make you learn this project and understand things properly. So make sure you understand this Docker Compose file. Now that we understood this, let's go and deploy this. But to deploy this application using Docker Compose, we need to have Docker installed in the server, and there's no Docker here. So let's go ahead and install it. So I have the commands ready. In this, I'm going to go ahead and run this command, Docker Compose. So this is the command to install Docker in your laptop along with Docker Compose. So you can see we are also installing Docker Compose here. Let's press enter, and this will go ahead with installing Docker along with Docker Compose. So we should be ready to deploy this application. Along with Docker Compose, there's also another important file that I want you to know, which is inside this src folder under Opentelemetry collector and then the config file. This is the file that defines what monitoring solutions do you want to use. So if you make changes to this file, you can use Datadog or Dynatrace or Splunk or any other tool in place of the default Prometheus monitoring solution. So if you want to use Splunk, Sumologic, Datadog, Logs.io, any monitoring tool, you need to make changes inside this particular config.yaml file. And this file is also explained here. So this is the explanation of the file, of what is this file and what is this TLP protocol. This is the protocol basically to collect telemetry data, and all the other things are explained here. So if you want to know more or go deeper into what are collectors, what are exporters, what are processor in Opentelemetry, you can check that out. And you can also read them on the official documentation. But to give you a quick context, receivers are used to collect the data, which includes traces, metric, logs from various sources like application or endpoints. Exporters then send this data to external system or storage, such as logging systems or metric platforms. Then processors are used to transform them or modify them and then export it to the applications. You also have connectors, which is used for extracting metrics from trace data for further processing or exporting. And then you have services, which define how telemetry data should flow through the system, specifying which receivers or processors or exporters are used for traces, metrics, and log. So I hope you will go through this properly and understand each component so that we can properly understand how this project is working. Now that we have done this and we have our Docker installed, we are going to be running the docker compose up command. So I'll copy this command and paste it in my server. So now Docker is installed. To confirm, you can run sudo docker ps. Docker ps is the command to see any running instance, any running containers. We don't have any containers as of now. So I'm going to run the sudo docker compose up command, which will create the containers from the compose file, as we can see in this VS Code here. So I'm going to be running sudo docker compose up and press enter now. You can see it's going to pull up all the images, and then very soon we will have all the services created, which includes Jaeger for tracing, all this microservices, product catalog, checkout, payment, currency, Kafka, Grafana, code service, shipping service. So there are so many different services, and which is why this DevOps project is a bit complex. But if you follow this video till the end, it should not be a problem for you. You should be able to do this project without any issues, and you should also be able to understand how observability works. So to give you a real world example, while this is coming up, observability is generally used to understand how is your application performing. And there are many big companies who are investing millions of dollars just on observability platforms to make sure that their application is working properly without any issues. Because there might be a company which is selling a product, and if their website is down for 2 minutes, it could be a huge business loss. So they want to make sure that their websites or applications are always available, always reliable, and this is why they used observability tools to check if there is any latency issue or if there is any CPU problem, memory problem, anything. This is why you need to understand observability as a DevOps engineer, because your job as a DevOps engineer or a SRE is to make sure that your applications are always available and always reliable. So doing this project will help you understand more properly how things work. And as I said, if your company is using any of the different monitoring solutions present here, then you could also do this project on that monitoring platform. So if your company is using New Relic, you can click on this and you get the files related to New Relics, which will include configurations that you can set up. In fact, there are many different monitoring solutions that have created demo on this project. So if I search for Otel demo, you can see blogs from Datadog, Dynatrace, Stackify, Splunk. Then there is Sumo Logic here. There is also Coral Logics, Honeycomb. In fact, this has become a norm. So every monitoring tool that is in the market, they are showcasing their tools or how it works using this Opentelemetry demo. This is why it is so popular, and you should be doing this, because this will help recruiters know that you have knowledge of observability and you can work with their monitoring solutions. So this application has been started. You can see notifications here. So it is getting started. We have all of these working. If your Kafka is showing error, or if there is any issue with Kafka, you need to check the RAM of your server. So RAM should be more than 6 GB or more than 8 GB. So make sure if there's any issue with Kafka, it's always a RAM. So we are going to wait for this to completely start, and then we can check our application. So it's all ready now. To confirm, you can run sudo docker ps, which will show you all the different containers we are running right now. So we have containers for payment service, for accounting service, quota service, checkout service, all of it. To access the application, you're going to copy the IP address and open this app on port 8080. So this is our application here. It's an Opentelemetry application, which is an e-commerce application to buy telescopes, binoculars, all of this. And it has different microservices. So there's a currency service here, which you can use to change your currency. You also have a cart service. So you can go to cart or add your products in the cart. Let's buy some binoculars. So I'm going to buy 10 binoculars and add to cart. Here is some demo data, and you can change this data if you want to see your particular data maybe in logs. But I'm going to go ahead and click on place orders, and this will place an order. So this is an application here, a simple e-commerce application written in different programming languages consisting of different microservices. So this will give you a real world idea of how observability works, because this is a very complex application. So you can go ahead, check out this application properly. If you have deployed it in your server, you can check out different things, card service, currency service, checkout service, ad service, payment service, recommendation service, all of this. So once I make this request, you can then see the generated data either on Jaeger or Grafana, all of that. So let's try to access Grafana now. So Grafana is available on this 8080 slash Grafana slash. Once I do this, Grafana dashboard will open up. Grafana is an open source monitoring tool that is used to create dashboards where you can see different metrics in nice charts or graph format. Grafana is actually very popular and used by many big companies including NASA, SpaceX and lot more. So they have community edition which is free and also paid version. So in here we have our dashboards created. We are going to have 4 different dashboards which you can see in this demo folder here. So we have demo dashboard, we also have Opentelemetry dashboard, Open Collector dashboard and then span metric demo dashboard. If you want to create your own dashboards, you can also do that in Grafana. You get information like latency. So how much is the latency for the front end service, request span, error rate, all this information is here. Recommendation rate, CPU, memory. So this way you can check your metrics in nice dashboards like this. So you can also filter out based on different services. So if you want to see memory or latency for an ad service, you can change that here. Also for FLAC-D service or maybe email service, all the information or all the different metrics for every microservice is present here. This is how you will be doing in your real DevOps project as well. So you can check out metrics for all the different services and explore this properly to understand how Grafana works, what are different dashboards and all that. Let's go on and check other dashboards present here. So I'm going to check span metrics demo dashboard, and here you can see information like latency for FLAC-D, top 7 services with mean rate over range. There are different dashboards which are properly showing different metrics that might be important for your business. So this is what Grafana is doing for us. Along with this, we also have some dashboard for particular component like Opentelemetry connector. So we got all this information just for Opentelemetry connector that is used to collect data from our application here. But to make this project more realistic, Opentelemetry also provides some fake data or generates some fake load using load generator, which you can access on load gen slash. This is using locust tool. So you can see that the requests are being made on the application. These are all fake loads just to demonstrate or make it more realistic that the traffic is coming on our application. So you can access that from IP address :8080 slash load gen. Along with this, for tracing, we have Jaeger, a very popular distributed tracing tool. Traces are used to understand how different microservices communicate with each other, how the requests are being made, and in this project we are using Jaeger to check that. So you can check traces for a particular microservice such as ad service, account service. You can also select what operation do you want to check. So do you want to check for the get ads or get random ads, Otel ad service. So any particular operation you can check traces for. You can also look back on a particular timestamp, maybe 5 minutes ago, last 15 minutes. You can also limit results. So let's check how the ad service is communicating, how the request is being made to ad service. So when I click on find traces, you can see all the different traces here. So when I click on this, we can understand that the load is coming from load generator, then to front-end proxy, then front-end, and then moving on to ad service. Using traces, you can understand the flow of the request, and if there is any issue or maybe the information is not sent, request is not made, you can actually find where is the problem inside traces. So this is how important it is using tracing in the microservices architecture. Along with this, you can also compare 2 different traces using Jaeger tool, and you can also look at the graph on how the request is being made. So the request comes from load generator to front-end proxy, then to front-end, and then to other microservices. So this will help you understand more about how communication is being made, and in case there is any issue, you can always check here. We will be making some changes in our architecture to see some errors, and then we can troubleshoot where is the actual issue, which microservice is showing an error. So you can also check traces for any other microservices. And along with Jaeger, load generator, Grafana, there is also OpenSearch, Prometheus. So you can look for all the different containers that are created when we ran the Docker compose command. So you can see you have container for Prometheus, which is running on 9090 port. You also have a container for FlatD, for OpenSearch. So logging in this project is done using OpenSearch, which is present on this 32797 port. So if you have port open, you can also check the OpenSearch dashboard. So this is what we have in our project. After you deploy the project, you should be able to see all these things along with the dashboards on Grafana. So we have dashboards for different components in our project. We have dashboards for the Opentelemetry collector. So if you want to see if the Opentelemetry collector is working properly or not, you can check the dashboard here. So we can also see processor, exporter, batch for it, all the important metrics that might be useful to see how our Opentelemetry collector is working. Now that our application is deployed completely, let's go ahead and make some errors in this project so that we can get some data or like metrics changing or maybe logs or traces showing some errors so that we can understand how observability actually works. So to make the changes in your application, you need to be enabling feature flags. So in the official documentation, if you search for feature flags, Otel, this is also present on my documentation that I have here. If you scroll down to the end, you can see that you need to make some changes inside a file named as. If you scroll down in this documentation, you can see we have a service, a microservice named as flag, which is responsible to make some changes where you can increase CPU, where you can fail a service, so which is known as feature flags. Then you can read about all the different feature flags that we can enable here. So we can make the add service fail, we can increase the CPU, we can make cart service fail, product service fail. All we need to do is change the value in this flagd.json file. These flags are enabled using a service or a tool named as flagd, which is a separate tool used inside our project. So we are going to make some changes inside this flagd.json and then see what changes are made on the different monitoring tools. So I'm going to copy this. Let's go to our server again, and we need to say sudo nano name of the file, which is inside source flagd demo flagd.json. Once I press enter, okay, I need to go inside the correct folder. I'm not in the correct folder, so I need to first go inside and then run this command. So sudo nano, and you can see there are different flags here. So product catalog failure, this has a description saying fail product catalog service on a specific product. Recommendation service is going to fail when you enable this. So let's try to make some changes and enable these flags. You can do that by specifying that the default variant should be on. I'm going to make this on. Also, I'll try to fail the add service. So add service high CPU, I'll say default variant equals to on. So we are trying to depict a real application, because when working on an application, when you get more traffic, you get CPU increased, your services failed, and that's how you can check in different tracing tools or different monitoring tools to understand what is the actual problem. Along with this, I'm also going to Kafka queue problem. I'm going to enable that variant as well, or the flag as well. So once you save this, do Control S and Control X to save the file and wait for some time. I'm going to do some operations on my Opentelemetry shop. So let's try to buy this telescope. Let's buy 7 of them. So we have seen different Docker containers created, but you can also do this project using Kubernetes. If you want me to do this project using Kubernetes, let me know in the comment section. You can do this on your local machine using Minikube, but the only problem that you are going to face is if you want to access any of these applications, you need to port export it, like port forward it, so that you can expose the application and then access it. As in Minikube, you cannot use a load balancer service, so you have to use node port or maybe cluster IP and then port forward it. So let's wait for some time, and then coming back to Jaeger here, we are going to check our add service for all operations from last 5 minutes, and very soon we should be able to see a red dots like this, which indicates that there is an issue or there is a problem with any of the service. So I'm going to search, click on find traces option. Right now there is no failure, but let's wait for some time, and then we should be able to see some red spots here, which can help us understand why is the issue caused or why is the service failed. If you want to understand things more properly, make sure you go through the feature flags page and understand what is going to happen when you enable a particular flag. So when you enable cart service failure, this is going to generate an error saying empty cart 1 out of 10th time. So now let's go and check our traces in Jaeger, and if I click on find traces here, you can see there's a red dot which indicates that there's an error. So there are 7 errors now, and using traces you can understand where is the error. So error starts from load generator here, and you can also get more information on why this is coming up here. Then we can see the error in the front-end proxy, also in the ad service here. So using this you can understand why the error is received. Let's also check few other microservices. So let's check the traces for microservice named as front end. I'm going to click on find traces here, and you can see right front end is working properly as of now. Let's check for the front end proxy, and you can see there's an error here. So when I click on this, I get the error saying recommendation service is failing, and you get more information about the application, where is it running, EC2 instance, all of that. And we got all these errors here, so you can see it's all red, which means something is not working. By clicking on them, and then you can see that the recommendation service is not working properly. You can see it says inactive. This is because of the Kafka service being failed. Also, if you check in your Grafana dashboard, let's check for the service, which is add service, and if I refresh this, you can see that the CPU has been increased. So now that we have enabled some feature flags to get errors on our application, let me do some operations, buy some binoculars, telescope, and then we can check metrics on Grafana, logs, as well as traces on Jaeger. So I'm going to go ahead and do some operations just to generate some data. So I'll go ahead and buy this comet book, and then click on place order. I'll also buy a flashlight. So let's buy 6 of them, add to cart, and then click on place order. Hopefully now after some time, once you make the change in the flag B file, you can check your dashboards for different metrics. So we can check the metrics here, or also here span metrics. I'm going to click on demo dashboard, and in this dashboard you can check metrics for different microservices. So this is the front end microservice, and you can see error rate for front end by span name. So we are getting some errors here. Also, you can also check logs. Right now this is not creating any logs, but you can check CPU for your front end service. Memory is also here. But if you want to check metrics for a particular service, let's say for ad service, I can click on ad service here, and you can see the data for ad service as well. You can see it says high CPU load pattern enabled. So we get an error or a log saying high CPU load because we have increased the CPU or enabled the CPU flag in the file. So we also get ads failed with the status this, which means we are getting the information to understand why is this issue coming up. So whenever you get failed ad, which means there's some problem with your ad service. Whenever you see high CPU load for this ad service, which means you need to scale it up. So these are the information that helps you understand what is failing in your application rather than checking each service. So you can also see other things here. So let's say cart service. So when I click on cart service, I can see the latency information here. Also error rates coming up. I can also see cart service is getting these different logs. This is a CPU and so on. Along with this, if you check other dashboards, you can also see latency, then span names, everything else. Let's check out traces and see if there is any issue or a problem made when setting request among different microservices. So I'm going to click on find traces for the ad service, and right now ad service is not showing any errors, but let's go to front end and click on find traces now. So front end is also working fine. We have to wait for some time before it shows an error, because as we have seen inside the flag, it can show you an error 1 out of 10th time. Like out of 10 it can show you an error once. So you need to wait and check all the time. So let's check for this load generation service first. So I'm going to go and click on load generator here, click on find traces, and we can see that there is an error here, also an error here, and an error here. So when you click on these red spots, which will define you what is the error. So you can see the error is inside the recommendation service. So in this you can check logs, you can also check processes, which will give you more information about the microservice. So you can also read this log, which will help you understand and troubleshoot things properly. So it says deadline exceeded. This is more likely a Kafka issue because they have also stopped Kafka. So this is how you can understand or get to know where the problem is, what to check, what not to check by checking traces in your Jaeger dashboard. Ad service works fine, there is no issue in ad service yet. As I said, the flags are enabled to show you error only periodically. So you need to try out and change different flags to understand things. I'm going to choose flag D, this service, and there is an issue here. So we got an error here. So let's click on this option. When you click here, you can see the error is in the front end proxy, and it has a warning, also a process here. So we got an error saying clock skew has been disabled, not applying calculated data for flag. So let's say your company is using something else other than Prometheus, maybe Dynatrace, Datadog, New Relic, Splunk. You can check this Opentelemetry repository, and if you scroll down below, you can see the same application can be done on all these different vendors or all these different monitoring tools. So you can do the same with New Relic, Elastic, Google Cloud, OpenSearch, Sentry, Splunk, Sumo Logic, Telemetry, Liatrio, Logs.io, Uptrace, CloudFuse, Datadog, Dash, Zero, everything. For example, let's say you want to do this with Datadog. So you can just search for Otel Demo Datadog. So I'll say Otel Demo Datadog, and all these different companies have their own blogs and demos explaining how you can use the same application on their platform. So you can see sending data from Opentelemetry Demo to Datadog. In fact, there is also a video created to explain you all these things. So we have the same thing. All you need to do is to change the file that I have explained you earlier, which is the Opentelemetry config.yml. Apart from this demo also uses their own connector. So they're also adding a connector here in the Docker Compose file. So you can follow this demo if you want to do the demo or this project on Datadog. Similarly, let's say you have Splunk, you can see this, say the same thing and say Splunk here. So now you can see how to deploy the Opentelemetry connector, how to set up the Opentelemetry demo in the Kubernetes. So then it will give you the steps on how to set up this application, and you will have the same application that we have done right now using Splunk. So you will have their own dashboard to check traces, metrics, and logs. So similarly, if I search for logs.io, I also have a demo here. So this demo explains me how I can go ahead with doing the same project using the logs.io. This is the same project that we have done. So all we need to do is change some settings in the files. So we have to add the tokens from my logs.io account to the server, so I can start using logs.io service or monitoring tool in place of the default Prometheus Grafana tools. So all I need to do is change the file in the config.yml file that I have explained you in the start of this project, and you need to put this data here. So to quickly show you, let's go into source file, ls. You need to change the file inside the Opentelemetry collector, which is Otel collector here. So if I do Otel collector, you can see there are two files here. This is the file that defines what tools to be used. This is the same file with the backup. So I'm going to edit this file just to have things securely. So I'm going to say sudo nano and Otel collector config extras.yml. Now I need to copy the same thing from the documentation here. So here we are defining the logs should be stored inside logs.io. Traces should also be stored inside traces.io. Same for Prometheus. So I'm going to just copy this and paste it. Once I paste it, I need to add some information, which includes the tokens, listener URL, and so on. So if you don't have an account, you can create an account with logs.io. So I'm now signed in with logs.io, and I'm going to be using this monitoring dashboard or this monitoring tool to set up our application. So I'm going to go into settings and click on manage tokens here. This will provide me with tokens that I can use. So I'm going to quickly put my tokens that is present in this data shipping tokens. Okay, so now I've added the information inside this file, and you can always refer to this document to understand what to enter. So you need to add your shipping token and the account region, which is going to be US East 1, but you can check your dashboard and check your region as well. Once you do that, you need to run this command docker compose up --no -build. So I'm going to run this command here, coming in the right folder, which is /. So this is where my docker compose file is. So I'm going to run the docker compose up --no build file, and I need to use sudo because I get permission denied. So I'm going to say sudo, and this will go ahead with redeploying my containers, and this time it will use logs.io to showcase my traces. So you can see traces are going to be generated here. Same for metrics, logs. So log.io uses Jaeger by default, also Prometheus as a backend. So it's going to be very same, but you can understand how to use other monitoring solutions. So I wanted to try out this maybe with Datadog or Dynatrace or Splunk, and also share your learnings on LinkedIn. Once you are done with the project, don't forget to delete the instance. You can go ahead with just terminating this instance, or if you want to stop and come back work on it, you can stop the instance as well. So once my application is deployed, I can get some data generated on the dashboard. Here you can see we are now able to see all the different services on logs.io here. Click on find traces, and we can find traces after some time because it is just set up now. So similar to this, you can do it on any other dashboards or any other monitoring tools. So this is how we need to set up observability using Opentelemetry Demo application. So this is the end of our DevOps project. If you have any questions, any doubt about the project, let me know in the comment section. If you successfully completed the project, make sure to share your learnings on your resume, also on LinkedIn. Don't forget to tag me. Along with this, if you want me to share the document, comment down observability project and I will share this document with you. I hope you complete this project till the end and also integrate it with your own monitoring tool. Let's see who completes this project first. Thank you and have a good day. Bye.